Hello, my dear students. I welcome you all to KLS Gokte PU College of Commerce and Science, Belgavi. This is our first lecture on topic classification of elements and periodicity in properties. This is Mr. Akash Vasan Nesarkar, lecturer in chemistry, Department of Chemistry. The key concepts of this topic are: we'll try to study the earlier classification of elements and their significance and need, and also we'll study the history of it. We'll try to understand the modern periodic table, long form of periodic table, and we'll study the classification of elements. In that, we'll deal with the metal, non-metal, metalloids, group 1, group 2, hydrogen, group 16, group 17, and group 18 elements. Also, we'll study the properties in periodicity such as ionization, affinity, magnetic and electronegativity, and some other periodic properties like volume, density, boiling, melting point, and oxidation, oxides, and halides. So, these are the key concepts of this topic. Now, before we start this topic, let me clear you this topic is entire theoretical one. You need to have the patience and the focus to understand this topic. So let us start. Need for classification of elements. See, all existing matter in our surrounding is made up of basic unit known as the elements. So all the surrounding is made up of basic unit, and those basic unit is known as elements. Initially in the year 1800, only 31 chemical elements were discovered. After some advancement in the technology in the year 1865, about 63 elements were discovered, and this created the need of periodic classification of elements. So many elements were discovered in the period of 1800 to 1865, and therefore it brings the curiosity for the periodic classification of elements. And presently we know that there are 118 elements. Out of these 180 elements, some elements are man-made, right? The periodic classification of elements in the modern periodic table is: when there were only 31 elements, it was relatively easy to study the properties of these chemical elements. Yes, obviously, if there are less number of elements are discovered in earlier chemistry, their properties are easy to study. Now, the number of elements has raised to 118. It would be very cumbersome to study properties of every element individual. And therefore, in order to ease the work, scientists started thinking about the method so that the study of elements can become simple to each one of us. They decided to organize the elements in a periodic table according to the available information available about the elements and the various characteristics shown by them. It was observed that elements show periodicity in their properties. Many tables were made to arrange the elements in an ordered manner based on their characteristics to study the properties of elements in a fixed pattern. Now, what is the importance of this periodic classification of elements? The first one that makes the study of element easy, and the second one helps in discovering the new elements. So the classification element took place. The elements in the periodic tables are arranged according to their properties, and the periodic table serves as an aid in predicting chemical behavior. The periodic table arranges the elements according to their electronic configuration. So we arrange the elements according to their electronic configuration such that elements in the sum column have the same valence electron configuration. So some of the elements will have the same electronic configuration. That creates the problem again. Periodic variation in a size and chemical properties are important factors in dictating the types of the chemical reaction the elements undergo and the kinds of chemical compounds they form. The modern periodic table was based on empirical correlations of properties such as atomic mass. Early models using limited data noted the existence of pairs and octaves of elements with the similar properties. So overall, the modern periodic table is based on the properties of the elements. The periodic table achieved its current form through the work of Dmitry Mendeleev and Julius Lothar Meyer, who both focused on the relationship between atomic mass and chemical properties. Meyer arranged the elements by their atomic volume, which today is equivalent to the molar volume, defined as molar mass divided by molar density. The correlation with the electronic structure of atomic atoms was made when H. J. Moseley showed that the periodic arrangement of these elements was determined by the atomic number, not atomic mass. So later on, the Moseley gave the suggestion and he proved that the elements in the periodic table can be determined by the atomic number. But earlier, the Mayer arranged the elements by their atomic volume, which is known as a molar volume. So both Dmitry Mendeleev as well as Lothar Meyer gives the relationship between the atomic mass and the chemical properties. So lastly, H.G.J. Moseley showed that the periodic arrangement of the elements was determined by the atomic number, not the atomic mass. Got it? Now let us go back to the history of the classification of elements. So DeBerner traits. So there are some various states as given by earlier in earlier traits. The first one, the German chemist Johann DeBerner in 1800 first observed similarities in the elements on the basis of their properties. So he observed that there are some similarities based on the properties of the element. He saw that there are group consisting three elements, that is traits, that have similar chemical and physical properties. Classification of elements into group of these three elements, each with a similar properties such that the atomic weight of the middle of the element was the arithmetic mean of the other two. The properties of the middle element were also in the halfway of both the elements. Daubernier called this grouping method as the law of traits. So this grouping method he named as a law of traits. Later on it was found that this law was not true for every element and hence it was not successful. So later on it is concluded that this law is not true for all the elements and it is not a successful. For example, lithium, sodium, potassium. The atomic weight of these elements are 7, 23, 39. Element calcium, strontium, barium. The atomic weight is 40, 88, 137. And element chlorine, bromine, iodine 35.5, 80 and 127. So this is the trends given by the Daubernier traits based on the elements on the basis of their properties. So lithium, sodium, potassium will have the similar properties. Chlorine, bromine will also have the similar properties, and calcium, strontium, barium will have the similar properties. But apart from these elements, there are many elements which shows the different properties. Next comes the Newland's law of octaves. In 1865, after the failure of Daubernier states, the English chemist John Alexander Newlands gave the law of octaves. It was the arrangement of the elements in order of their increasing atomic weights. So he arranged the elements according to the increasing atomic weights, in which it was observed that every eighth element has the properties similar to the first, just like the eighth node of an octave of music concert, and therefore it is called as the Newland's law of octave. This law was also dismissed as it was only true for elements of up to calcium. So it is true for only up to calcium. Apart from that calcium, this law does not hold good. So this rule is known as law of octaves. Means very first and the eighth element will show the similar properties. Helium, lithium, atomic weight is 7. Element sodium, atomic weight is 23, and potassium it is 39. Right. So these are the things which is this is the data given by the Newland's law of octaves. Next comes Lothar-Meyer classification. He plotted the graph between the atomic masses and the atomic volumes for the number of elements. He found that elements with a similar properties occupied the similar position on the curve. So the elements which shows the similar properties occupied similar position on the curve, and he given the data, and with that data this law holds good for up to some extent, but not for the all the element. Then comes the history of classification of elements in that Mendels Periodic Law in the year 1869. His periodic table was based on the periodic law only. The physical and chemical properties of the elements are periodic functions of their atomic weights. He said that the physical and the chemical properties are based on the periodic function of their atomic weights. He arranged in order of their increasing atomic weights in a such a way that elements with the similar properties are placed in the same group. So the elements which are having the similar properties, he placed those elements in the same group, and he arranged the elements with the increasing order of their atomic weights. It consists of 7 horizontal rows. So it consists of 7 horizontal rows, which is known as a period. Mendeleev's original table consists of 8 vertical columns called groups. So Mendeleev's periodic tables contains 8 vertical column, which is known as a group. These are numbered as Roman number 1, 2, 3, and 8. So remember, according to the Mendeleev's periodic law, there are 7 horizontal periods and 8 vertical columns, which are known as a group. So we can say 8 groups are present. But it has some merits as well as a demerit. The merit is what? It is a simple to study the chemistry of the elements. It helps in predicting the discovery of new elements on the basis of the vacant spaces in the periodic table. He also left some vacant spaces for the discovery of new element. It helps in correcting the position of the some element based on their atomic mass. It also helps to correcting the position of some elements based on their atomic masses. Defect. So these are the defects of the Mendele's product. That is, position of hydrogen is not fixed. The position of hydrogen is not fixed. Also, no separate positions are given to the isotopes. Order of increasing atomic masses is not strictly followed in the arrangement of the elements. So some of the elements are not followed by the arrangement order of increasing atomic masses. Okay, so some elements are not followed by this Mendele's periodic law, but this law holds good at the maximum level. Next come to the long form of periodic table, that is the characteristics. See, in the long form periodic table, the elements are arranged in the order of their atomic numbers. So in the long form periodic table, the elements in the periodic tables are arranged according to their atomic number. Atomic number of an element is equal to the number of protons inside the nucleus of its atom. So later on, elements are arranged according to their atomic number. Okay, and it has some general features of the long form periodic table are: the first one, there are in all 18 vertical columns and 18 groups in the long form periodic table. So there are 18 columns which are known as groups, and therefore we can say 18 groups are present. These groups are numbered from 1 to 18 starting from the left. So from the left side we have, it is given the numbers, that is 1 to 18. There are 7 horizontal rows called periods. Also there are 7 horizontal rows which is known as a periods in the long form periodic table. Thus, there are 7 periods in the long form periodic table. The elements of group 1, 2, and 13, 17 are called main group elements. The elements which are present in first and second and 13 to 17 are called as the main group element. These are also called typical representative or normal elements. Next, characteristics. The elements of group 3 to 12 are called transition elements, and the elements with atomic number 58 to 71, that is cerium to lutetium, occurring after lanthanum, are called lanthanides. Elements with atomic number 90 to 103 are called actinides. These elements are called F block elements and also the inner transition elements. So F block elements are called inner transition element, D block elements are called transition element, S block elements are called alkali, alkaline earth metal, and group 13 to 17 are called P block element, that is the non-metals. Some empty spaces have been left in the periodic table so that the elements that will be discovered in the future can be placed without disturbing the trending periodicity of the elements. So this is a very nice research they have done. Now, periods. The horizontal rows are called periods. So there are 7 periods. So we know that in a periodic table there are 7 horizontal rows which is called as a periods. Each period consists of series of elements. That is simple. Having the same valence shell and the corresponding to a particular principal quantum number. To a correspond to particular principal quantum number. First period contains 2 electrons. It is the shortest period. Second and third period contains 8 elements. First period contains 2 elements. Second and third period contains 8 elements each. These are short period. Fourth and fifth period contain 18 elements each. These are long periods. Sixth period consists of 32 elements and the longest period. Seventh period starting with the francium is incomplete and consists of only 19 elements. So this is about the periods. There are 7 periods. In first period there is a shortest period. First period is the shortest period and the fourth and fifth period is the longest. Sixth period is the longest period. Sixth period consists of 32 elements, so it is known as the longest period. Now groups. The 18 vertical columns are called groups. So there are 18 columns in the periodic table which is known as a group. The elements belonging to a particular group is known as a family. So each group is known as its own family and it is usually named after the first element and it is usually named after the first member or the first element. For example, elements of group 1 are called alkali metals because these are bases soluble in water because all the elements present in group 1 are soluble in water. Next one, elements of group 2 are called alkaline earth metal. Elements of group 15 are called nicogens, that is suffocating smell. Group 16 are called chalcogens, overforming elements, and group 17 are called halogen, that is the salt forming elements. So according to the some properties, these groups have the common name also, that is nicogens, chalcogens and halogens. Next one is the blocks. The periodic table is divided into 4 main blocks, S, P, D, F, depending upon the subshell to which the valence electron enters into it. Elements of group 1 and 2 constitute S block. Elements of group 13 to 18 constitute P block. Elements of group 3 to 12 consist of D block. And elements of SP blocks are called normal or representative elements. Those of D block elements are called transition elements, and with A block elements are called inner transition elements. Right. So this is about the periods, groups, and the blocks. Okay. Now look at here. Whatever we have studied in previous slide, I will once again repeat this. See, there are 7 periods: first, second, so this is second, third, fourth, fifth, sixth, and 7th period. So these are the 7 periods present in a periodic table. Okay, and next is what, there are 18 groups: first, second, third, fourth, fifth, sixth, 7, 8, 9, 10. Like this, 18 columns are known as 18 groups. Okay, in first period there are 2 elements, so this is the shortest period. In second period there are 1, 2, 3, 4, 5, 6, 7, 8 elements are present, so this is also shortest period. Even the third period is also shortest, but the fourth period, okay, 1, 2, 3, 4, 5, 6, it contains maybe 18, so this is the somewhat longest period compared to fifth and sixth. So sixth period contains 32 elements, that is the longest period. So these elements are arranged in the periods as well as the groups. So there are 2 groups which are known as alkali and alkaline earth metal. These are 1, 2, 3, 4, 5, 6. which are known as main group elements, and group 3 to 12 are known as transition element, and these are known as lanthanide and actinide. Those are known as a block element. So there are four block. First two groups belong to S block. Next, these group 3 to 12 belongs to D block, and next from boron to neon, that is P block, and this is lanthanide and actinide is known as a F block. So there are four blocks. Okay, and each group has a named according to their name of the first member or some chemical or physical properties. For example, group 1 is called as alkali metal because all the group first elements, when it is dissolved in water, they form the base, and therefore these are known as a alkali element. In the same way, the group 2 elements are called as alkaline earth metal because these are found in a earth crust. So this is about basic things we need to learn. Okay, so this is S block, D block, P block, and here it is A block. So there are how many periods? So there are 7 periods, and how many groups? 18 groups. Groups are vertical column, periods are horizontal rows, like this. You remember this. How many elements are present? Totally 118 elements are present, and in this some are man-made elements are also present. Okay, so remaining things we will study in the next class. So thank you one and all.